Electric vehicles are already changing the way we drive, but what if the biggest breakthrough hasn't even arrived yet? For years, solid-state batteries have been described as the holy grail of EV technology. More range, faster charging, improved safety. The promise sounds almost too good to be true, and until recently, it mostly lived in research labs and press releases. Now, that might be starting to change. A US-based battery company called Factorial Energy says it's making serious progress toward bringing solid-state batteries into real production vehicles. And unlike past hype cycles, this time major automakers are directly involved. So what's actually happening here? First, let's talk about what makes solid-state batteries different. Today's electric cars use lithium-ion batteries with a liquid electrolyte inside. That liquid helps move ions between the battery's electrodes, but it also has limitations. It adds weight, requires complex cooling systems, and in rare cases, it can pose fire risks if damaged. Solid-state batteries replace that liquid with a solid electrolyte. That one change opens the door to much higher energy density. In simple terms, that means more energy stored in the same amount of space, or the same energy stored in the smaller, lighter pack. For drivers, that could mean significantly longer range without making the car heavier. Factorial Energy has been working on this technology for years, and now it says its solid-state cells are reaching important performance milestones. The company is targeting commercial production before the end of the decade, with 2029 often mentioned as a realistic timeframe for scaled manufacturing. That's not next year, but it's also not some vague someday promise. What makes this development more credible is who's backing it. Factorial isn't operating in isolation. It has partnerships with major global automakers, including Stellantis and Mercedes-Benz. These aren't small pilot projects either. They involve real vehicle integration in validation programs. Mercedes, for example, has already tested solid-state battery technology in prototype vehicles. Reports suggest those test cars achieved dramatically extended driving range, far beyond what most production EVs offer today. If that kind of performance becomes commercially viable, it would fundamentally change how people think about electric cars. Imagine driving 600, 700, even 750 miles on a single charge. For many drivers, that would eliminate range anxiety completely. But range isn't the only benefit. Charging speed is another major factor. One of the biggest complaints about EVs is the time spent waiting at charging stations. Solid-state batteries, in theory, can handle faster charging while maintaining stability and longevity. Factorial has indicated its cells are capable of charging from a low state of charge to near full in under 20 minutes under the right conditions. If that translates into real-world performance, charging an EV could start to feel much closer to refueling a gasoline car. There's also the question of safety. Solid electrolytes are generally more stable than liquid ones. That could reduce fire risks and potentially simplify battery pack design. It may also allow automakers to reduce some of the heavy cooling systems currently required, making vehicles lighter and more efficient. But it's important to stay realistic. Solid-state batteries have been 5 years away for more than a decade. Scaling production is extremely difficult. Manufacturing solid electrolytes at high volume, ensuring durability over hundreds of thousands of miles, and keeping costs competitive, those are major engineering challenges. Even if the technology works perfectly in prototypes, building millions of units affordably is another story entirely. That's why the late-decade timeline makes sense. Automakers need time to test, validate, and integrate these batteries into full vehicle platforms. Supply chains need to be built. Factories need to be retooled or constructed from scratch. Early solid-state models will likely appear first in premium vehicles, where higher costs are easier to absorb. Over time, if production scales successfully, the technology could trickle down into more affordable segments. So, what does all this mean for the average driver? In the short term, not much changes. Lithium-ion batteries will continue to power most EVs for years. Improvements to existing battery chemistries are still happening, and today's electric vehicles are already better than they were just a few years ago. But in the long term, solid-state batteries could represent a true second generation of EV technology. Longer range, faster charging, lighter vehicles, potentially longer battery lifespan. That combination would remove many of the final psychological and practical barriers preventing widespread EV adoption. We're not at the finish line yet, but for the first time in a while, solid-state batteries don't feel like pure speculation. Real companies are building them, real automakers are testing them, and real production timelines are being discussed. If everything goes according to plan, the electric cars arriving at the end of this decade could look very similar on the outside, but under the floor, the technology could be radically different. And when that shift happens, it won't just be an upgrade. It could be the moment electric vehicles truly go mainstream.